So from the same amateur radio acquaintance as before, we've got another Audioline PT341, and as he's put here, it had an 80 channel illegal board or whatever done, which is removed, and perhaps he's missed something which they do, and who's to tell what they do. He'd like the meter replacing. Yeah, well, I've got about 3 of them which would like the meter replacing. I think one thing I have to point out is we buy scrap chassis. Often these come up on eBay, but by the time I buy a scrap chassis, I'll give you an example. That is probably what I'm going to buy. So there's no metalwork, there's certainly no meters. That's what you get. All that cosmetic stuff's long gone. So we do about 350 CB repairs a year, and there's probably about 2 sets that we end up scrapping out of those repairs because they are beyond, what you can do. So there are times that we do generate some scrap, and you know what? As often as not, things like meters on those type of sets don't work either. So what you do. We might pull it apart and make it worse. I don't know. Anyway, we'll get the set into something like before. At least the last one turned out all right. So I better take all the lids off, and I better put the soldering iron on ready, because that is bound to be something which we're going to need. So let's hope. He sent 4 sets in. There's 2 Midlands as well. Are they 3000 ones, 4000 ones? Can't remember what he's asked for on those. Now you have to appreciate these are 40 years old, and when you can get meters, they're not going to look the same, and they're also going to be a lot of money. Look at those Midland. Is it 48s? Meters are nearly always duff on those. Something like £28 to replace. It's just a ridiculous price. Come on, they can't be worth more than 5, can they? Right. I'm glad he labels these. It's very good. Excellent. So he's done the capacitors again on this. And that one and that one. Something he is doing, which I wouldn't, is he's replacing the 16 volt capacitors with 16 volt, and he'd be better off changing them for 25 volts or 35 volts, so there's a bit more headroom. When they manufacture any type of equipment, be it a television set or the CB radios, they're going to put the lowest voltage rating possible in a consumer product like this, and the radio is going to get applied to 13.8, 14 volts, so you're already pretty near the top voltage that the 16 volt capacitors can handle. So the life of about 2000 hours of the average capacitor is specified at that maximum voltage. So you're getting at a far and away greater life if you go up a bit with the voltage. And the rule of thumb is you can't go more than 10 times the voltage. So with that, we'll see if we can see anything. There's no point just powering it up without having seen something. Don't think I put away the one I got out. I'll look at these wires because it was black, brown, red, orange. Look, they've got those two shorted together again. So that's wrong, isn't it? So we'll remove the blue one, which I've shorted together with the yellow one. So we know the yellow one. I'll just cut a bit of that off and re-tin it a bit. So these, these have been around 40 years, as I keep saying, and it wasn't till me doing that other one, which had the front panel wiring messed with, that I realised it neatly followed the resistor colour code, which is engineering excellence. So just make sure there's nothing cut down there. It doesn't look like there is. So we know from the resistor colour code 0, 1, 2, 3, 4 there isn't a green wire. We know that because we had a bit of fun wondering where the green wires were in Japan that day. So it goes straight over to blue, which is 6. And then we should have violet. Yeah, look, there you are. They've been permanently shorted together. So 5, 6, of course. Yes, we know 5, so 6, 7, 'There's a grey wire. Is that one, which has been left dangling, but sleeved off. I've got 20 minutes whilst the washing machine finishes. That's what I'm waiting for. That's why I'm just cramming this in. I think we're hopefully doing the catenary wire across to the new building today, which will carry the tannoy, the internet LAN cable, and also a remote cable for a radio transmitter, I intend having there. Okay, so now we've got 0, 1, 2, 3, 4, nothing for 5, 6, 7, 8, 9. Now I feel like we can power it on. So it could be possible the 8 volts is missing, because shorting those out can end up with the 15 ohm resistor being killed, but I think he's changed that. Anyway, put the power supply on, see what happens. Well, more would happen if I had that on. So as he says, we've got no display. So there's no 8 volts. That's normally what's going to happen. I haven't got the manual out yet, have I? So let's see what's on that resistor. Not a lot's the answer. Why aren't I getting full rail voltage? I thought these were the chassis on these was negative, but looks like it's floating. Tell you what, we'll take it to there. No, we won't. We'll take it to there. I like changing my mind. So on the underside of that capacitor, have we got 8 volts? And the answer is we haven't got 8 volts. So without 8 volts there, we're not going to have anything lighting up. If I switch this to PA, does it work in PA? And the answer is no. Unless I'm in the wrong socket. No, I'm not in the wrong socket. And what have we got in the ordinary socket? Switch back to CB mode. There's a bit of noise there, got no receive light. What we've got to do is to find out why we haven't got our 8 volt rail. So digging the manual out, we got there, didn't we, eventually? Digging the manual out for the Realistic 2000. That's that 15 ohm resistor 93. So have we got anything on the emitter? Well, just go through the 3 legs of that transistor. It's transistor number 19. Transistor 19, we should have 9, 12 and 8. 9, 12 and 8. Nothing. Full rail voltage. Nothing. We've got rail voltage on the far side of the resistor. What about this side of the resistor? Nothing. think we'll whip the resistor out in case it's burnt out. I'll turn the power off. I think he's changed it, but it's our first port of call. I'll use this multimeter. I don't think we've got anything else handy, have we? What about this LCR? The one with one prod at the moment. Ah, there we are. Resistor 15 ohms. So we'll clean that hole out and we'll put it back. And we'll pause the video. Okay, so put the resistor back. So I think the next thing to do is to check that the Zener diode is not short circuit, because chances are that's going to be short circuit. So if that's the capacitor he's changed, then let's put the meter across in ohms. Make sure we've got continuity across that capacitor. Now it's not always going to give me a proper reading in circuit. Is that the capacitor, or am I mistaken? That's the capacitor. So that's the Zener. Just do a little check for continuity there. Little check for continuity. Oh, look, we've got a short there. I wonder if that capacitor is short circuit. It's negative down. No, it's not, but we'll change it anyway because of its age, 4.7 microfarads. So we should still have a short across where that lives. I think that's going to be our fault. So I'll just put a new capacitor in that, and then they're all of 16 pence. I'd be daft to put the old one back because of it being 40 years old. It's like taking car engine apart, which is 40 years old, and then putting all the oil back, which you took out in the same gasket. You just wouldn't do it. And we'll have a look at the circuit diagram and see what's in parallel with that. So that capacitor capacitor 2. Let's look at the layout. Capacitor 2. Yeah. So let's see where this is on the circuit. Yes, the capacitor 2 is on that main receive rail, just there. So any short circuit on that rail so resistor 2 is 1.5k, so any short circuit would have to be huge for that to happen. So it can't be anything here because it would present 1.5k. So if that capacitor was duff, it wouldn't be a direct short circuit, it would read 1.5k. Now if that decoupling capacitor was short circuit, then of course that would be the same short circuit. I can't imagine that being the case because those kind of capacitors don't fail unless its legs have actually got twisted together. Just can't imagine capacitor 3 being short circuit. So we go to the volume control. Is it the volume control? RF gain wiper. Surely that can't be short circuit unless it's been messed with. So capacitor 3, let's just have a look at that. When I get the right radio. Capacitor 2, see if we can see. So capacitor 3 is that one there. I can't really imagine this ceramic being faulty. Right, we'll whip it out. Certainly be a first for me if that was the case. Helps if we take the right part out. Put the wrong part back. Right, we'll check this for continuity. I just cannot imagine this being short circuit. And no, it isn't. So we should still have a short circuit. We have across that rail. Well, I better do some thinking off camera. Right, so roll on 2 days, and we have actually got power on this radio. I've got the green RX light on. There's no display, it transpires, because the flexitrack, which I've now removed, the flexitrack which goes between the board and the channel selector switch, was open circuit on all but 3 of the dozen or whatever there are. I've not counted them. Conductors in there. Now the other thing, the reason there was no 8-volt rail is I'll just change glass and put the soldering iron on. This resistor 92, can't see it quickly. Anyway, if you remember on the previous set, resistor 92 is there. On the previous set, resistor 93 was burning up because of the short circuit. Now, of course, I've covered those. Hopefully, I've done that on the video. Of course, these were again wrong because it's been messed with, hasn't it? It's been an 80-channel illegal modification, which the customer, my radio ham acquaintance, has modified back. So it's there. So what happened was, when I tested the voltage on resistor 92, I've got voltage at, shall we say, the body end and not at the flying end. Sorry, I got it at the flying end, but I hadn't got it going into the transistor. And what I found was that it was pushed in, but it wasn't soldered properly. So whether or not that's been introduced over the years, that fault, or whether it's something that was a factory fault is another matter. Anyway, that gave us the 8-volt rail back. So we'd got the green RX light, and I knew there was power up to the synthesizer chip. So that is open circuit, that's been removed, that's a faff. And what we're going to do is put ordinary wires. They're all going to be the same colour. I could put loads of different colour wires in, couldn't I? And how much more time consuming would that be? So we'll just do that, and it's quite time consuming. See you in a bit. Okay, we'll go back into record. That's what we've ended up doing, and we'll power it up and see whether we've got back our channel display. Now, I don't think this still wasn't working in PA mode, so this has got other issues as well. So I'm not expecting it to end by getting the channel display to come back. But you never know, it might be able to select a channel because it will get a valid code. On the Cybernet sets, if it gets an invalid code, it will usually select channel 9, assuming emergency. But I'm not sure the Toshiba chip does that. So we'll go into speaker. We'll plug the mic in, so we've got receive going through. Put the power supply on, switch on, and we've fixed it worse. No, we haven't. So we've now got a display. Aha! And we've got a short somewhere. So let's see whether we've got anything on receive. Okay, we'll go back into record. That's what we've ended up doing. And we'll power it up and see whether we've got back our channel display. Now, I don't think this It still wasn't working in PA mode, so this has got other issues as well. So I'm not expecting it to end by getting the channel display to come back. But you never know, it might be able to select a channel because it will get a valid code. On the Cybernet sets, if it gets an invalid code, it will usually select channel 9 assuming emergency. But I'm not sure the Toshiba chip does that. So we'll go into speaker, we'll plug the mic in, so we've got receive going through. Put the power supply on, switch on, and we've fixed it worse. No, we haven't. So we've now got a display. Aha! And we've got a short somewhere. So let's see whether we've got anything on receive. And the answer is no. So we've got anything on transmit. And we've not got the transmit light, the receive goes out. So does it now work in PA? I'm not expecting it to do so. So in PA mode. 1 2 1 2 1 2. So we do have very, very quiet PA. 1 2 1 2. Testing 1 2. So I think we need to look into what's happening there. Well, I'm glad I'm not charging by the minute on this job. Right, well, a few days later, let's select picture in picture. A few days later, we've got this working. I've got it on channel 19 at the moment rather than channel 20 because it doesn't work on channel 20. So let's put it on channel 20. And see whether we can get it to work. I'll just change the signal generator. We'll see what's amiss there. Now it could be my dodgy wiring, but I doubt it. It could be a broken bit of track. Could be an open circuit data line on the phase lock loop chip. Anyway, who wants it to work on 19? So his meter isn't actually faulty. I think it's a bit sticky, but he can sort that out himself. Lot of capacitors changed all around this phase lock loop section, and that's basically brought back operation. Lots of small value ones like 0.47, 0.22, and that. So presumably it worked kind of in its illegal 80 channel mode, but not when brought back. But I think part of that was with the broken flexitrack there. So here's what we're going to do. It works on channel 19, doesn't work on channel 20. So looking at the service manual at the truth table. So what I could do with is a rule. I won't say ruler, otherwise you'll say that's Queen Elizabeth II. So, channel 19. Low, 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 high, high, low, high, high. So let's compare that with channel 20. So, oh, there's quite a difference. Oh, this was going to be, I thought that'd be really, really simple. Like one change, but there isn't one change, it's a dramatic change. So we'll have a little look at the other side of the board and see whether there's something that's blatantly obvious. I mean, obviously I need to clean this up with isopropyl alcohol. Looking at, let's just zoom in on this. Right, to tell you what, we'll pause the video and we'll do the isopropyl alcohol now. So looking at the soldering around there, which of course is all what I've done. Two things I will mention. There was a cut track between that pin and that bit of track. Neatly done, very neatly done with the scalpel, and a cut track there, and so my radio amateur acquaintance has missed those. But that didn't bring back operation, that actually made it worse. Now looking down here, we can kind of, because it's in a lower level and the light, see whether I can see where we're prodding. I'm looking down at these. I think that could be, yes, there's a broken track. There is a broken track. So that's going to be what's wrong. So the best thing to do there is we'll put a bit of wire in. See if there's some bit of solid wire kicking around on the bench. You never know. So I don't want to just bridge the gap. I just want to, we'll put an actual bit of wire in. I found a little bit of hookup wire. Got the power off. And this should restore channel 20. So that was another thing I was chasing, was the fact I'd probably fixed the radio quite a few capacitors back, but the radio was still not giving any VCO voltage, simply because it was a miscode. And as I said before, if you've got a set with an LC7137 synthesizer, the chances are that it will assume channel 9 if it gets a miscode, and so you straight away you think, I'm selecting channel 20, it's selecting channel 9, that's a miscode, it's assuming emergency, and it's going to channel 9. But it doesn't seem like the Toshiba TC9119 has that little bit of cleverness. In fact, I actually find them a bit more susceptible to damage than the LC7137s, and they're so hard to come by. I mean, where do we get one apart from out of another set now? I understand there's some in Brazil, and if I buy something like 200, I can have them for something like $20 each. Well, I'm not investing that kind of money, because nobody wants to pay for even $20 for one, I don't think so. The sets are 40 years old, although they're much loved. Unfortunately, a lot of them have been ruined, like this one has. So, you never know, this might work when I've just chopped that bit off. Good. Switch it back on. Hey! Channel 20. This video is not going to get uploaded for quite a few days. I'm doing this, I think, on the 2nd of January 2022. And my phone line for my house phone went down on Christmas Day. I was first aware of it at about 9:30 in the morning. I was trying to get off to church and somebody was trying to phone me. And every time I picked it up, it went to nothing. And then they thought I'd fallen out with them because I was putting it down. Anyway, I did realise who it was, and I phoned them on the business line. That call cost me a fortune. Well, £1.67 is a fortune to me. We don't normally have a phone on the business line because we don't want any business. How good's that? But we have the phone there, the business line for the internet. So I inadvertently logged off YouTube. So I thought, oh, I'll log back in. We're doing two-staged verification, said a nice sign. Log in with a trusted device. Well, I was using the normal computer, so I don't know how trusted that wasn't. But it isn't a tablet or a or a telephone, you know, a telephonic device with a screen. And so that's not a trusted device, even if I've been using it 15 years. So they said you can also ring on your house phone for a verification code, but the phone line's down. Alternative means, well, I've pressed the alternative means button, we've gone through an email, it says allow 48 hours as a security protocol. So that's what's going to happen, because I've done that this morning, it's still this morning, so in about 22 hours time we should get access to the YouTube account back. Wow! So, over to the service manual. I know we did one of these sets last week from the same customer, but can I remember? Of course I can't remember. Channel 40. There we go, channel 40. So, meter on. Better put the camera into the normal position, and we'll put the inset to the power meter. Switch the little test meter on. The Aldi test meter, or is it a Lidl test meter? So, the test point, which I do know, is there, and we are looking for transmit. Let's turn that volume down. It does actually transmit. It's doing low power at the moment. It's doing 400 milliwatts. We've got 1.97 volts, and we're supposed to have 3.5. So let's get that realigned. And that's with L17, which is the nearest one, the one with the wax in. There we go, 3.5 volts, plus or minus 0.1. Then on receive, we're going to want, they say do this with an oscilloscope, we'll be using the synod meter on receive. And I'll tell you what, we'll do that right now. So switch the synod meter on. I've said before, these sets were made before synod meters really hit the laboratories. So here we go. So we've got 2779125 on the signal generator. Actually, we haven't checked, and there's not a lot I can do about it, but how close to being on frequency is this radio. So 2779125 is what we're looking for. Oh, we're on channel 40 still. 2779125 is what we're looking for. It's slightly low, it's within spec, but there's no trimmer on these, and if the crystal's duff and it goes out of spec, we need to replace the crystal. It's not a good design, that, but there you are, it's what you've got, but it's near enough. So we're going to tune the radio up with that frequency error. So my signal generator, I'm going to reset, instead of 2779125, we'll reset it to 2779102. And then we know that it's all being set absolutely spot on to what the radio is expecting, and we don't end up with it being lopsided and non-sinusoidal. So we'll look at that on the synod meter. Select the synod meter on here. Have it to about 6 decibels, or dog biscuits. Because chances are this has been fiddled with, so we'll just... To be honest, that was pretty close. Right, let's go back to transmit. So I'm happy the VCO is set. We're on channel 20. So maybe we're on low power. I think we are. So we'll go back to that. I will select high power, boing straight across. We're at 13.8 volts on the power supply. The radio's doing 3.95 watts. So we'll just whip through that. It will drop a little bit as it warms up. That's 4. That's 4. Don't think we're going to need to go much further than this. That's still 4. And that's 4.0 something, so that's fine. Okay, so that's, we can turn pages now. Oh, they do receive first, which is daft. So we want in low power, we want it to be 0.4 of a watt. It's now 0.44 because we've improved it a bit. So it's variable resistor 5. It's not, you know. It's variable resistor 4. Changes glasses. I expect that's the one up there. It is. So that's 4.4. And then we want the meter. Now that's a bit sticky, so, or it looks like it's a bit sticky. We want to check that with variable resistor 3, which is there, that we've got 4 watts showing on the meter. We're in the centre of the red zone there. Huh? Oh, well, blow me, I've done it when it was in low power, haven't I? So low power, hardly moves. High power, it swings across. And your crocodile clip comes off. Put that on this side. We'll put that on this side. We'll put that on this side. Right, deviation. Wallow, 1 2 1 2. Oh, we've got no audio, so let's have a look. Mic gain's at full. Just check we're tuned in. 1 2 1 2. Wallow. Don't think wallow. I think we were tuned in. So that's actually a bit low at 2 kilohertz. One, two, 1 2, testing 1 2, wallow. That's it. Don't think they ever exceed 2.5. So that's the transmitter setup. So moving over to the receiver. Let's go back to the. Oh, we'll do the detector. So we'll show that on the oscilloscope, and we'll take the bench light off. We'll give it an S9 equivalent signal of 100 microvolts. We'll turn the volume till we get a meaningful waveform. That'll do. And we'll just do the detector. Tell you what, we're going to move this meter out of the way because the meter is in the way. And so is Mr. Chippy's crocodile clip. He'll be back tomorrow, so I'll be in trouble if that isn't back on his bench. So the detector coil is that one, if I remember rightly. Yeah, a little bit out. We just want maximum Remember, this oscilloscope's just across the speaker output. There's nothing clever about it, and it's, although it's a 10 meg scope, it could be a 1 meg scope. We're only looking at audio. So that's that done. That's going to improve the receive. So we now go to the sine of the meter and put the bench light back on. Let's get that for about there. See if the RF gain's at full. It is, and it works. So it's not brilliant at the moment, but these aren't as sensitive as Cybernet sets anyway. And for 12 dB, we've got 1 microvolt, which is probably about where they are. Let's see what it says. It's 10 dB anyway on these. It says needs to be better than 1, and it's at 0.9, so it's already, they'd like it to be 0.5, but they'd like it to be better than 1. So we'll go through these. So I'll set that for about 4 dB so that the receiver's not being saturated. Now you'd expect this to be slightly out, because if it's been illegally 80 channel, they'll have hopefully tried to compensate by tuning it on channel 1 of UK or channel 40 of CPT. So we'll bring back its excellent sensitivity, hopefully. I can't remember whether where we are with that, L4, L5. Can't remember whether that's receive or transmit. L14, no, it's transmit. Just go through some of those on a higher signal. This can just sometimes improve our 20 dB response. No, that's as I've taken the tool out, that's changed. Or is this hand capacitance? I'll do it with the other hand. Yeah, it doesn't like my right hand. Perhaps this one doesn't either. Luckily it's a church organist, I can use either. So what have we got now? Have we got any improvement? So for 10 dB we've got 0.89. So we've gained a little fraction. It was 0.9, it's 0.89. So it's in spec. So I've got an S9 signal on. We should have the meter reading S9 if it isn't sticky. I still think it's probably a bit sticky. Signal meter. That's S9. Let's see whether we can see it moving properly. Put that bench light slightly out of the camera. Yeah, it's a bit sticky. Not something I want to play with, because experience has told me that you end up fixing it worse. Right, if it was my set, perhaps, they're all sellotaped together, you know, these, and once you take that sellotape out, Right, what does that leave us with? Well, it just leaves us with the squelch. So what I want, turn that off. No, we'll go over to the attenuator controls. So what I want is 100 microvolts at which the squelch opens when on full. I've been able to squelch that out, so I just need to adjust the preset, which is VR1. No, it's not, it's VR2. So I want it to just open. There, it's just opened. So I've gone down to 30 microvolts and it's off. 100 microvolts, it's come back in. So that's exactly where I want it. So let's look at the sensitivity of the squelch control. I'll put the signal generator to standby, set threshold, switch the signal generator on, see where it comes in. So this is 0.4, 0.5, 0.6. 0.6 of a microvolt it's coming in, and it's dropping off at 0.5, so that's a useful squelch. Now I said we've got 0.8 of a microvolts for 10 dB synad, but let's see how we can hear this down to. So I'll turn the squelch down, that's 0.3, 0.2, just over 0.2 is about what we can hear it down to, so that's very reasonable. So with that, let's check that tone control works. I don't know whether this now works in PA. It didn't when it came in. Testing 1 2. Helps if we switch to PA.
Testing 1 2. 1 2. Testing 1 2. Wallow.
Yeah, well we've restored that, so that's fantastic. I think that was a plethora of capacitors. To be honest, apart from the ones in the speech processing there and the odd one in the receive, I don't think there's many left. I've seemed to own some in the preamp side there, but anyway, I've changed an awful lot of them, but they're so cheap it doesn't matter. I think parts cost on this is going to be about £1.60, you know, there's nothing in it. So, with that, we'll put it together. So I'll pause the video while I do that. Except when we come to it, the speaker's duff. So, in fact, I just put the hot off my lead, which proves it's working. The connection, the flexible connection down to the coil, is snapped off. So I might have to leave that for him as well. We might have some square speakers in stock. It's supposed to be 16 ohms, we certainly haven't got that. Let's see what the service manual says about that. What I don't want to do is overload the audio amplifier. Speaker 501. Oh yes, 501. Well, it doesn't tell you, does it? So that's handy. Audio output load 8 ohms, so you know, with the speaker in it's 16, which is probably there to reduce the volume. Okay, well I'll see if we've got a square speaker, but if we haven't, we haven't. Right folks, well we've got to a stage, and what we've done, had to wait a few days for a speaker to arrive. speaker that arrived didn't fit, so I got on to a few of my friends, and one of my friends has sent me off a set that had a duff phase lock loop. So effectively he's ended up scrapping the set. He has sold me the speaker. It's a very low hours set, and of course the reason he's got a duff phase lock loop is exactly the same reason that it's been faffed about with and has had the silly illegal modification. So we've got a speaker in at great expense, and I've also had the front panel off. So here's the moment of truth. I've had the front panel off because I wanted to sort out the transmit light, which wasn't working. And what's happened is the front panel's obviously been taken off before, and now it's working, and it's been put back incorrectly, so it had pushed the LED so it was actually shorting itself out. So it wasn't faulty, it was a matter of redressing the wires. While I had that off, I took the sellotape off the meter, and I have just backed off one of the bearings a fraction, and we'll just see whether we can. Yep, that's now reading full scale. Let's see whether we've got our signal generator somewhere near 7, 9. So that should be S9. Let's make sure we're on frequency. So we'll just retrim that now the meter's not apparently sticking. Signal meter. There we are, S9. And when we key up again, it's full scale deflection. So I have sorted his meter out. So we've sorted everything out. I've put the front through the dishwasher. I wouldn't normally do that with a customer, and the knobs, because to be honest it was all filthy. So that has helped. We'll solder this back on, and hopefully the radio will start making some sensible noises. So sorry about the length of this video, but there's such a lot wrong with this set. Well, it certainly made a clonking sound as we soldered it on. Turn up the volume. Yeah, there we go. So I'll just take the power off. We'll reapply it from the power supply end. Pop some screws in. This has been about 10 days on here, because what's happened is, of course, we're waiting for the speaker to arrive, waiting for the second speaker to arrive, and it's the only RF bench we've got in operation at the moment. As you know, there's building work happening here, and the concentration now is in restoring the pipe organ in the private chapel we've had built. So all this stuff is a maximum of 1 per week. I think we've got about 8 sets stacked up. We've got a radiogram coming in on Monday, and all these jobs will be done at the pace of 1 per week. So it's all right asking me if we'll look at your set. The answer is yes, but it'll be months away. And of course, if it isn't in the queue, it isn't in the queue. So we're not looking for business. Mind you, we never are. And we've even got all the screws. So we've got 2 more sets to do from this customer. Whether or not we'll be able to do anything with these Midlands, but that's something we're going to be able to start on today. So it's Saturday today. I think this has been on the bench since last Thursday. Those could do with buffing up a bit. Those crocodile clips back on. We don't have power leads for sets, so if they don't come in with them, this is what happens usually. Apart from the Maxcom ones, which we make the leads. Right, So there we are, back on. We'll put this on the aerial and we'll just do our final little test. And then it'll be scratchy corner. One and a Roger. So it's 12 noon. One and a Roger. Dead as a dodo here in the middle of nowhere. So I say we'll do an on-the-air test later. Thanks for watching. I say it's been 10 days. There's your Audioline 341, which was, to be honest, beyond economic repair, but it's been done. Thanks.